this is a webinar focusing on advanced vehicle dynamics. So what I've basically prepared is several kind of groups of content. So I want to introduce you to the concept of vehicle dynamics and the importance of it within automotive development. And I want to focus on analytical vehicle dynamics. So I'll introduce you to what that is and some of the methods that we can work with vehicle dynamics analytically, which has a lot of advantages and is a gift of modern technology. Then I want to explain to you who works with vehicle dynamics, what kind of companies use it, what kind of things they do with vehicle dynamics, and specifically analytical vehicle dynamics. And we'll go into current trends in the vehicle dynamics field, where the technology is going, and kind of what the market is. Then I'll run through a brief case study, kind of running through exactly what a vehicle dynamics development process might look like within an OEM or a motorsport vehicle developer, for example. Then we'll talk briefly about career options, like what kind of things are open to you as a vehicle dynamics, what kind of opportunities to work on various projects you might have. And then finding work in vehicle dynamics, how to become employable as a vehicle dynamics engineer. So what is vehicle dynamics? So in a brief definition, it's the study of responses of a vehicle to forces generated through motion. So obviously a car can brake and accelerate in longitudinal motion. You have steering, so you can steer the wheels to generate lateral motion. And you also have the addition of road inputs into the vehicle. So in a vertical sense, traveling over bumps, undulations in the road, what effects they have on the vehicle body. So there's really two main approaches or two main subsections of vehicle dynamics. So you have road cars, the development of road cars, and that's very much a comfort-oriented approach. So you're trying to do things like minimize body accelerations. You're trying to isolate the driver from various vibrations and things like that coming through the vehicle chassis. And often that's a trade-off between kind of as you develop more for comfort, you have less of a performance-oriented vehicle. So race cars is really the complete opposite of that. Things like comfort, driver experience in terms of vibrations and ride comfort, that's completely not a focus in vehicle dynamics for race cars, and the approach is purely performance oriented. So you're trying to maximize the accelerations that the vehicle can develop, both longitudinally and laterally. So the importance of vehicle dynamics. So the first point really is understanding vehicle dynamics is key to characterizing the vehicle performance. So that is creating an objective view or an objective understanding of the vehicle. You have subjective approaches, which is kind of like the driver commenting it's too much body roll, for example, not compliant enough over bumps, too much vibrations coming into the steering wheel. These are all subjective. But the advantage of the objective approach is that you then you kind of can put numbers on things. So in a most simple sense, what is the lateral acceleration that a vehicle can develop? Or what kind of vertical acceleration is the body experiencing over a certain road surface? These are the advantages of understanding vehicle dynamics. So it also allows a comparison between vehicles. In that sense, if you can characterize one vehicle in terms of its responses, you can then characterize another, and you have a method of comparing various criteria between certain vehicles. As I mentioned earlier, it enables objective assessment. So rather than quite vague human-oriented feedback, you can kind of get into parameters, so parametric assessments. And yeah, understanding vehicle dynamics allows performance to be tailored for specific applications. So there are certain vehicle dynamics qualities that you'd want to promote for a circuit racing car, or there are certain things you'd like to promote for off-road driving. Perhaps other things that you'd like to do for like a purely comfort-oriented vehicle, like a BMW 7 Series or something similar to that. But the important thing to realize with vehicle dynamics, especially with a performance focus, is that it all starts with the tire. The tire is the only part of the vehicle that's in contact with the ground. So understanding the tire and the influence it has is very important. That runs throughout, whether it's road car or race car. So analytical vehicle dynamics. Vehicle dynamics is heavily related to classical mechanics, which, if some of you are mechanical engineering students, you'll have studied, I'm sure. So it's pretty much just the application of forces and moments and the understanding of how they influence a vehicle. It can all be described with mathematical equations, which means that it can then be assessed mathematically. So analytical vehicle dynamics is just simply using like simulation software, such as Adams, as I've mentioned here, MATLAB, other systems like that, just to use the advantage of computer processing power to execute those calculations and work a lot quicker and more efficiently than humans, essentially. And another advantage of analytical dynamics really is that I'm talking about computer simulation-based assessments here, is that it allows virtual loads to be studied. So you can create a virtual environment for your chassis. Firstly, you create a virtual chassis, then you create a virtual environment, and it gives you a method of understanding the vehicle's responses without actually building a physical vehicle. Key advantages of this really are that it reduces development time. Previously, before the rise of computer-oriented analytical vehicle dynamics, you would have to build a physical prototype of a car, and then you'd have to make changes to the physical vehicle. This all takes time and effort and human resource, materials. So having the advantage of creating models very quickly in a computer obviously greatly reduces development time. And likewise, because of that, because you're not physically building a vehicle and you're not organizing physical testing at testing facilities, it reduces development costs. So it's very important today to everyone who uses vehicle dynamics to be able to use analytical methods to provide assessments. It also provides understandings which are difficult to obtain through physical measurements. So certain parameters, for example, dynamic camber gain, tow compliance, they're very much parameters that are difficult to measure physically. So using the advantage of mathematical models, you can provide very quick and accurate assessments of those. So, as I mentioned, the analytical method is nothing magical. It's simply maths that mathematical equations that are solved on a computer to obviously increase the calculation capacity. It streamlines the development process, as I said. and they really have a wide range of complexity. You have simple analytical methods such as Excel spreadsheets that you can use to perform very quick and easy calculations of the more simpler phenomenon. For example, things like weight transfer, weight distributions, lateral accelerations, perhaps. And then at the other end of the scale, you get full multi-body analysis software. So MATLAB has some capability of this. And I guess the industry leading software is MSc Adams, which I'm sure a lot of you are familiar with. So there's really a scale, and analytical methods are really open to anyone who understands the maths behind what's happening. The important thing to remember is that analytical methods always require correlation with real data, because there are various assumptions that are made to simplify things, and the vehicle dynamics involves a lot of very dynamic and non-linear quantities, such as tire characteristics, that are not very easily simulated. So there always requires some kind of link back to a physical test. For example, you could never develop an entire vehicle and fully understand its real vehicle dynamics just using analytical methods. There always requires some level of correlation. It's like a development cycle or a feedback loop. So who works with vehicle dynamics? You have OEMs, so original equipment manufacturers such as Ford, Jaguar, Range Rover, BMW, all your favorite brands. They all use vehicle dynamics in their vehicle development. You have motorsport teams, so Formula One teams, World Endurance Championship teams, so teams developing Le Mans cars, DTM. It's really a wide range of anyone developing a vehicle chassis will use some kind of vehicle dynamics understandings and simulation methods. Of course, niche vehicle manufacturers, so companies that are making lower volume cars, obviously with lower budgets, they will still use vehicle dynamics, in particular analytical vehicle dynamics. And also specialist companies, so consultancy services are used within the industry. This is partly what I do for my work. So companies and smaller projects sometimes need vehicle dynamics expertise, but they don't wish to kind of bring in and develop a vehicle dynamics department within their business. So they go outside and outsource their requirements. Okay, so current trends. As I was saying, it really, all high-level vehicle dynamics development is based in analytical approaches. So things like MATLAB, Adams, they feature heavily. I think you'd struggle to find a company that is doing any serious vehicle dynamics work without some kind of analytical software. The only other real alternative is doing hand calculations and very basic things like that, but that doesn't get you very far today. So another trend at the moment is an increased emphasis on driver assistance. So obviously autonomous vehicles are under very heavy development at the moment, but also ADAS, which is advanced driver assistance systems. Things like lane changing, autonomous driving, of course. Some of the more advanced vehicle dynamics assistants that use cameras and very complex control systems to automate some of the driving process of a car. That's a very fast, very rapidly growing area, and yeah, there's a big focus on control systems and software. So understanding it moves away from classical vehicle dynamics somewhat, and it merges with mechatronics and some other fields, but vehicle dynamics is at the root of it. Yes, increased use of mechatronics. So steer-by-wire systems, systems which are able to operate the steering wheels individually of driver input. Brake-by-wire systems that are able to use the brake without having a direct input from the driver's foot. Rear wheel steering. These are all mechatronic systems that use software and some kind of actuation to manipulate a physical quantity. So there's a lot of focus on control systems and software at the moment in the vehicle dynamics field. So a case study. A company is developing a new high-performance road car. So the first thing that they will do here is use analytical vehicle dynamics to characterize the vehicle. So that starts with creating a mathematical model in a software such as MSc Adams or MATLAB. That model is a complete representation of the vehicle. So every joint, every suspension member, the spring damper, the tire will be represented, things like bushings and kind of NVH related items. Everything is represented in the vehicle model. And this is an important stage because if the vehicle model doesn't receive accurate information, then it produces inaccurate information. So this is a very important phase. It's the initial phase. And from that, the vehicle will be subjected to various tests, various simulated tests, such as constant radius cornering to understand what the vehicle's lateral acceleration capacity is. Things to understand steering. So you'll kind of input various things like step steers or sine wave inputs to the steering system to understand how the vehicle scores in control and stability. Other things such as braking acceleration tests. These are all performed, and there will generally be targets that each parameter has to meet. So that is kind of a feedback loop that starts, and the vehicle architecture is tailored to meet the targets. So after that process, you have to make physical parts, of course. So, well, before that stage, I suppose, it's kind of elaborating on what I was saying earlier. You have, the steering system will be developed using vehicle dynamics. The suspension kinematics will be developed. So things like dynamic camber gain, toe, all those quantities are developed digitally. The spring damper system, so spring rates and damper rates, what kind of stiffness are you needing? What influence does the spring and damper have onto the contact pressure between the tire and the road surface? And developing methods to minimize the variation in that contact patch pressure. And also a big thing, chassis mass distribution. So calculating where the center of gravity should lie on the chassis. So BMW are quite well known for this in creating equally balanced chassis. So 50% of the mass over each front and rear axle. That is something that they will kind of develop and understand how to place heavy components within the chassis and what their effect on the weight distribution is. So all these things are gone through digitally before a part is made. And as a last step, parts and vehicles are made. And as I was saying earlier, correlation is very important. So after parts are made, after the vehicle is made, every test that the digital vehicle was subjected to is then performed on a physical vehicle as a kind of last step. And there will always be a difference, but it's important. It's an important process to understand where those differences come from and whether the model needs adjusting. And that development loop, that feedback loop must continue. So once a good level of correlation is met between the physical vehicle and the digital vehicle, the vehicle dynamics process is said to be complete in essence. So that is a process that generally does take years. A vehicle development cycle would last maybe 3 years. So the vehicle dynamics team will constantly be active in working with the chassis and the powertrain and the body teams to make sure that the vehicle dynamics targets are respected. This is kind of a thing that's driven by market and competitors benchmarking, etc. So vehicle dynamics is a very wide field. There are a lot of opportunities that are available to people wishing to get into vehicle dynamics. From the most simple things, such as, well, not a simple process, but it's obvious what it might involve. The vehicle and automotive and motorsport chassis design. So you could start work with a company such as Ford, for example, working on developing their chassis. And likewise with suspension design, developing control arms and suspension kinematics, working kind of at a lower level and maybe with a less wide scope than complete chassis design. Simulation engineering. So as I was mentioning, the analytical methods are all kind of simulation based. So you can find work simply working with computer simulations and interfacing with other teams such as the chassis design teams and the suspension design teams to kind of develop the vehicle. Controls engineering, as I mentioned, there's a very heavy focus on controls at the moment. So you might be able to find a situation or a career route where you're working with things like dynamic stability systems, the software-based vehicle controls, rear wheel steering, as I mentioned. That's something that I've seen on quite a wide range of road cars recently. And then you can go into the real pure motorsport areas, such as race and performance engineering. So obviously vehicle dynamics feature heavily in race cars, and perfecting the vehicle dynamics is quite a big thing at race events, developing the vehicle setup. I'm sure some of you are aware. So having a vehicle dynamics background is a very strong advantage when you're working with those kind of things. And kind of finishing up, finding work in vehicle dynamics. So what kind of things do employers look for when they're hiring their vehicle dynamics staff? So I guess the primary thing is they'd like to see further education in mechanical engineering or something very closely related. I did automotive engineering, and they're very similar courses. Even aerospace engineering, there are a lot of parallels between vehicle dynamics and kind of dynamics in an aeroplane, in an aeronautical sense. So a lot of the concepts and ideas very heavily based in classical mechanics. So anything that exposes you to those kind of areas is definitely an advantage there. They'll also expect you to have very solid understandings of fundamental principles. Some courses will provide this, but often the course kind of introduces you to a subject, and then it's your responsibility to improve your learning and keep absorbing information and researching and developing your skills there. So that's always going to be a positive. As I was saying, the main areas of vehicle dynamics involve forces and moments based in classical mechanics, system dynamics, so dynamic responses to various situations. So the things like the lumped mass approach, which I'm sure a lot of you have heard of, sprung a mass suspended by a spring and damper. So kinematics also, which is defined as the motion of objects without reference to the forces causing that motion. So very important in linkages such as suspension systems. These are areas that you should look at focusing on as well. And yeah, vehicle dynamic modeling techniques, which is essentially what this course or the future course that will be that I'll be developing with Skill-Lync is involving. Experience in the use of analytical methods. Yeah, that's another big one, as I've kind of covered a lot in this webinar. So yeah, software such as Adams, MATLAB, being proficient in these kind of things will certainly be something employers would look for.